Today we will begin our first worksheet on acceleration. Now let's remember that acceleration is any change in speed or direction of an object. So remember the graphs of it being like so and like so. Okay, so with that, let's go ahead and work this first problem. Remember, acceleration can be negative as well as positive. So, number one, while traveling down the highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the automobile's acceleration? Remember that negative acceleration indicates a slowing down or deceleration. So the driver slows, so this one will be negative. Now acceleration is the final velocity minus your initial velocity. All this is divided by time. And your units are usually meters per second squared, or if you speed up in miles per hour over a couple seconds, it's miles per hour per second. So there's your units. Most of the time it's this, when it's going to be meters. Yeah, miles per hour, it will be that, which will be later on this worksheet. So our initial velocity was 24 meters per second. We slowed down to our final velocity of 15 meters per second. So we have 15 minus 24 and our time right there of 12 seconds. So this is all divided by 12. So we have to do the top first, which gives us a negative 9 over 12. So our answer is a negative 0.75 meters per second squared. So that's basically how acceleration works. Number two here. It is also going to be a negative problem. Number three, it comes to a complete stop, so that means we're slowing down, so it's also going to be negative. And I wanted to work a positive one with y'all. Cars rolling down an incline for sight, it starts and ends at, okay, so this one's positive. Speed increases, so this one will be positive also. The back side. When she climbs a hill, a cyclist slows down from 25 miles per hour to 6 miles per hour in 6 seconds. So that will be negative. Alright, starting from rest, so this is 0 to 42, so that's going to be positive. After traveling for 6 seconds, the runner reaches the speed of 10. Alright, so this is positive because it's starting from 0. Starting at rest, so that's positive, and rolls to a stop, so that one's negative. So I want to work a positive one with you, so I'm going to go ahead and do the car accelerating to a speed of 42 miles per hour at the end of 4 seconds. So remember, A equals V F minus VI over T. So our final is 42. Our initial was 0 because it was at rest. And this all took a marvelous 4 seconds. So 42 minus 0 over 4, which gives us a nice little acceleration of 42 divided by 4, which is 10.5. Now, here's what's different between these. This is going to be miles per hour per second. Okay, so that's 2 worked out for you. I guess I'll go ahead and work out a third and leave you 7 to work out. Guess I will go ahead and do, I guess we'll do another negative, so number 10. So, acceleration equals final minus initial over time. So, rolls to a stop. That is our final velocity. Starts at 7, so it's our initial, and there's our time in seconds. So, rolls to a stop. So 0 minus 7 over 3. So negative 7 divided by 3 is negative 2.3 meters per second squared. Okay. With that leaves you all with, alright, so number 1 has been done. Leaves you with number 2, number 3, 4, 5. Now remember, a nice sign means it's going to be negative. Negative 4 and 5 are going to be positive. Alright, see, 6 up here is going to be negative. And remember, its unit's going to look like that. 7 was positive, 8 was positive, 9 is positive, and we did 10. So, on the back, you just need to do number 6 at the top, then number 8, number 9. So it's just 6, 8, and 9 on the back to go with the 2 through 5 on the front. All right, good luck out there. If you have any questions on how to do this, just let me know. I know this is our first shot at acceleration. It's a little bit different than speed, distance, and time. There's a whole bunch more acceleration problems out there. So good luck. If you have any questions, just ask me. I'll be here. I'm available to answer them. All right, good luck. Bye.